How does an alum crystal made in a lab within Gen Chem dropped in the middle of a chemical vial in the HE10 lab by students in stress and disarray not grow any crystals within 10 days? This little vial of solution from one trial has sat a while, which does not make me smile because there's been no change, because that's very strange. By day 10 there should be some crystals arranged. And every day I turn off my lights when I leave my room. Within the gloom it struggles to get some light up, and thus with the curtains drawn it can't get any sun. The alum is ready to beg, steal, borrow or barter to get some sunlight. Wow, though it doesn't matter how, our solution needs to evaporate some water now. Put the solution in a window where some sunlight is allowed, but keep it in the dorm and then watch some crystals form. Well, the lack of the crystals may be because of the chemoid wired rounded twice to be careful with the sample type. Could get no evaporation and thus no crystals came. So now it's just a waiting game. It's now a game and I will get some alum crystals. I said I'll get some alum crystals. And though they have not quite formed yet, but I'll just wait. I'll just wait. And now it's 10 days later, not greater science written. Now let's see some chemistry that is written on the board with some scientific calculation. Later we'll talk about this mathematic causation. So first we use a balanced equation to see what the ratio of components is to be. This equation for the entire reaction, we find the limiting reagent by some actions. There is a little bit that we do with this method that we use. We could have been dumb or obtuse without a scent of restitution, but with dimensional analysis that we learned that 9.7 grams should have been returned. Now that we know how much we should get out, that's called the theoretical yield without a doubt. We can use this equation how it's meant to be used, and with this you can find the true percent. With this you can find the percent. With this you can find the percent. With this you can find the percent. With this, just use math. Percent yields 156. Though that seems very wrong to you, you probably would say that it seems way too great. But that's probably because some impurities were still there, or because we didn't dry the product completely in time. The percent will be high. Oh, alum's in this bottle now, but we cannot spot it. There might be something developing at the bottom. I still have some faith that my alum will be formed. I made it well by following the procedure quite perfectly, and now I'll just try to understand. There's a reason it's not there. For now I'll just wait. What did we make here? Alum crystal solution. Hello fellow chemists, my name is Maria-Manuel Miranda, and I'm here to tell you about my new Broadway show, Alumander Chemilton. It is important to note that this show is based upon true chemistry and mathematics, some I'd like to share with you now. Through the process pictured here, called dimensional analysis, and conjugation with the balanced chemical equation showed earlier in the video, we can find that 1.02 grams of aluminum we began with should result in 9.76 grams of alum. We go through this process by knowing that 1 mole of aluminum is equivalent to 26.98 grams of aluminum. We also know that 2 moles of alum are produced for every 2 moles of aluminum consumed, and that 258.2 grams of alum is equivalent to 1 mole of alum. Going through this process, multiplying the tops and then dividing by the bottoms, numerators and denominators for us mathy people, we find that 9.76 grams of alum is theoretically made. We can then plug this into our equation for percent yield. Percent yield equals actual yield in grams over theoretical yield in grams times 100%. And we find that there is 156% yield.